All right, I've gotten a few questions about internal EMF and internal resistance on batteries, so I thought I'd take a minute and try to explain that a little bit. So the idea of EMF is that that's the amount of voltage that's coming from sort of the chemical part of your battery. There are other things going on in a battery. So inside a battery, that we're going to lose some of that voltage to the wiring and the connections and the way that it's hooked up, and maybe it has its own monitoring system. So conceptually, the the chemical part of the battery is putting out more voltage than you receive when you get to the terminals of the battery, right? So if I think about a battery, something like a car battery, I have these two things, right? So I have this chemical reaction that's going on, and then other stuff going on, and then that's connected to my leads. Right? So what I measure outside of the battery is going to be the voltage that's actually useful to me, but that's not necessarily the same voltage that's produced by the chemical reactions happening inside. So we call it chemical reaction inside the battery. We call this EMF, or electromotive force. So that's the amount of energy that's being used or being generated, right? So your battery is generating a bunch of energy. Some of that energy is going to be lost as it goes through resistors or internal resistance, and then the rest of that is what you get to use for your circuit that you might be interested in. So the way that we deal with this is that we say, well, I don't know, there's a bunch of stuff going on in here, but what I'm going to do is I'm going to pretend that I have two things happening inside my battery. I have this EMF, I have this thing that's generating voltage, and then I've got essentially a resistor, right? So it's more complex than that internally, but functionally I can replace it with a single resistor. And so that's what's being shown on this diagram here. So this is showing my battery is consisting of two things. It has this chemical reaction that's producing some electromotive force, or is generating some voltage, and then it has some internal resistance. When you see the electromotive force, you could just replace that with the word voltage, right? So it is generating some voltage, and it's losing a little bit of that energy before it gets to the terminals of the battery. So the way we're going to represent this is we'll throw a resistor in there. So what I'm going to do is I'm going to now have a circuit that I can deal with, right? So if it tells me the EMF is 12 volts, but I'm not getting 12 volts at my battery terminals, I'm losing some of that to the resistance, I can still use like a loop rule to figure this out. Right? So I'm going to have a way to deal with a battery that has electromotive force in it. So, let me look at a couple of these problems. Right? So the first one, number one, says I have an old cell with an EMF. Right, so this is my battery is generating 1.5 volts, right? That's what they're telling me. It has an internal resistance of 1 ohm. So I'm just going to hook this up to a resistor, and this resistor here is going to have a resistance of 1 horseshoes. How much I currently flow if it's short-circuited. Right? So it's saying, well, if that's the only thing that's this in my circuit, how much am I going to get out of this? Right. Oh, there it is. Right, so I can now, I can ERV this, right? So I know this is the voltage. If I do a loop rule going around this, that I gain 1.5 volts going here, so I must lose 1.5 volts here. So what's the current? So close V. So I want to know the current, which is going to be V over R. So I must be losing 1.5 volts over 1.0, so I'll have 1.5 amps that must be coming through there. Right, so that's the maximum amperage that I can get. So notice what the idea is, that they're telling me that I'm losing some internal voltage. Number 5, let's say, so an automotive battery has an EMF of 12.6 volts. Okay, so I'm going to have some battery, and the voltage across here, so the EMF this generation is 12.6 volts. That's how much I have from a chemical reaction that's going on inside my battery. Has an internal resistance that's pretty small, so I'm going to have an internal resistor here, 0.090 horseshoes. Right? And this together makes up my battery. This is going to hook up to my headlights, right? So I've got a light. Internal resistance, a total resistance of 6 ohms. What's the potential difference across the headlight bulb? They're the only load on the battery, right? So they're saying, well, what's the voltage here? Right? So I want to loop rule this, right? So I'm going to go around. So the sum of my voltages must add up to 0. Right? So I'm going to have positive 12.6 volts. I'm going to have negative IR at this this internal resistance, and negative IR at the headlamps. Well, I don't know what this one is, so I'm going to have to make a little table and figure out what my total resistance is and find the current, right? So this is in series, so the current here is going to be the same as the current here. So let's figure out what the total resistance is, and then I can figure out what the total current is, and then plug it into here and solve for this, right? So I need to know what the voltage drop is here before I can figure out what the voltage drop is here. Okay, so total resistance, resistors in series, right? I'm just going to add those together, right? So my effective resistance is going to be R1 plus R2. So my effective resistance is going to be 0.090 plus 6. So I'm going to get 6.09 horseshoes. And I can find now the current from this. Remember, so ERV IR equals V. So my current now is going to be V over R. So I have a total voltage of 12.6 coming from the EMF of the battery, and a total resistance of 6.09. And I don't know, I can get something really close to 2. Beforehand, so I'm going to get 12.6. Battery's dead. Divided by 6.09. So I get 2.069 amps. So now I'm going to go back to my loop rule. I can find the voltage drop at, I can find the voltage drop here. So my voltage at that resistor, my internal resistor, is going to be IR, or it's going to be 2.069 times that resistance, 0.09. And I get 0.186 volts. So the voltage at the light bulb here is going to be simply, so I have to add these all together, so I have 12.6. I lose 0.186, so the remainder must be here. I can almost do that in my head, so that's going to be 12.414. It's going to be the voltage here is going to be the difference of those two. Anyway, some ideas about how to take advantage of internal resistance and EMF. EMF is just another way of saying that's the voltage that's being generated by the battery. Hope that's helpful. Talk to you soon. Bye.